We're now going to simplify exponents. And the way that we do this is we look at the following. So here's our rules. Each base can appear only once. You're only allowed to see one x, one y, and as far as numbers go, you're allowed to have one number on top and one number on bottom, and they can't have anything in common if you have a fraction. The second rule, each exponent on those bases must be positive. No negative exponents. And finally, each power to a power needs to be evaluated. In other words, you can't leave it as x squared cubed. It needs to become x to the 6th, 2 times 3. So we're now going to demonstrate this with two problems. We're going to start with 3x squared y over 5x to the 5th y to the 6th quantity squared. And there's two ways to do this, but the way that I always recommend is that you go from the inside first and then deal with the outside, just like the order of operations. So I'm going to start with the numbers. 3 over 5 doesn't faze me. They don't have anything in common. So we're going to stay with a 3 on top and a 5 on bottom. Our x squared over x to the 5th, though, the 5 is bigger, so we're going to get 1 over x to the 5th minus 2, which is 1 over x cubed, which means I have x cubed on the bottom. And y over y to the 6th is the same thing. The 6 is bigger, so 6 minus the 1 that's there is y to the 5th, also on bottom, so it goes on bottom, and then we square. Now we can use the quotient to a power rule and get 3 squared over 5x cubed y to the 5th squared, which 3 squared is 9, and on bottom we're going to get 5 squared x cubed squared y to the 5th squared as we use the product to a power rule. Well, 5 squared is 25, x cubed squared is x to the 6th, and y to the 5th squared is y to the 10th. And here's our simplified answer. We have one number on top, one number on bottom. They have no common factors. There's only one x in the entire thing, and there's only one y in the entire thing. Let's look at one that's just a little bit trickier than that. Suppose we have 12x over 3y to the negative 2 power times x to the 4th y squared over y to the 5th to the 3rd power. So here we're going to deal with both of these separately. We're going to start here. 12x over 3y, the 12 and the 3 becomes 4x over y to the minus 2. And since this is in a separate parenthesis, I can deal with him at the same time. Y squared over y to the 5th. The 5 is bigger, so it stays on bottom. We'll subtract 2 from it and get 1 over y cubed. So I get x to the 4th over y cubed cubed. Well, the negative power means I need to turn this upside down. So the y goes to the top and the 4x goes to the bottom. Now we can move our power inside, and I'm going to skip a step and move the square to both. So we're going to get y squared over 4 squared, which is 16x squared. And here I'm just going to move to the top and the bottom, x to the 4th cubed over y cubed cubed. This gives me y squared times x to the 12th over 16x squared y to the 9th. Now I can do the same thing. Y squared over y to the 9th is 1 over y to the 7th. X to the 12th over x squared is x to the 10th on top. So my final answer is x to the 10th over 16y to the 7th. Notice I just started on the inside and worked my way out until I was only left with one of each base and simplified fractions, positive exponents, and no powers to powers.